Okay, and we're now recording. All right, so we're getting near the end, folks. Welcome to May. That means we're done this month, as you know. So, okay, some quick comments again about the test. Some of you were doing okay on the test. Whoops, this thing closed on me for some reason. Let me try it again. Okay, so the test, some of you said you didn't get a chance to finish. I took that into account when grading. So I tried to grade more lenient because of that. And in addition, pretend there was a bogus question 9 and 10 and you all got 10 points on it, provided that you submitted the homework and you took the test. So if you didn't take the test, you don't get the 20 points. You still get a 0, of course. Okay. Speaking of which, if you miss a test, remember you get to drop one exam. One exam gets to be dropped, which could include part of the final, but not all of the final. Okay, so some of you may be having the attitude, well, I get to drop one exam. I've done well in all the exams. Maybe I'll just drop this last exam. You could do that, but mathematically, it's better if you take the final exam. That means there's less pressure for you to do well on the final exam. Okay, the final exam, even though you're taking one exam, it's to be thought of. You think of it as taking several 100-point exams each. And to check the syllabus exactly what the point value of the final is. Let's see, final exam is worth 300 points. Okay, so the way you really want to think of the final exam, if it's worth 300 points, is it's just like you're taking 3 100-point exams, even though you're not doing that. That's the way it's going to be scored. Okay, so when I grade your final exam, you get a score between 0 and 100, and then you pretend that's test 6, 7, and 8. Okay, of which they're all the same grade. Okay, so let's pretend you get 100% on the final. Then my grade book goes 100, 100, 100. Okay, the worst extreme is if you don't take the final, then it goes as 0, 0, 0. Or if you get an 80 on the final, it looks like 80, 80, 80, test 6, test 7, test 8. Then out of those 8 scores, 5 tests and 3 from the final, then 1 gets to be dropped. So that's the way it works. Okay, so you could say, I'm going to drop this 5th test and not even do it, but then that's more pressure for you on the final exam. So that's the way I construct it. You should not skip the final. If you skip the final, it goes 0, 0, 0. You get to drop one of those zeros, but not the other 2. And you should know, of course, that getting a 0 is not very good for your average. Okay, but everybody has the option. Well, it's not really an option. The computer automatically does it, of dropping your lowest score, which could include one of the 5 exams. So you say, I missed an exam, that's when you get to drop. Okay, or part of the final exam. So again, the final exam, okay, you're not taking 3 different tests, but it's graded like 3 different tests. You take it as one, you get one score between 0 and 100, put down 3 times. Okay, so then out of those 8 test scores, then you get to drop 1. So that's the way it's thought of. Okay. All right, you should have gotten your score back unless you didn't submit any homework. If you didn't submit any homework, then like I said, you don't get any score. That means it's a 0. And I should have emailed you back your score. And I also sent the video on the solutions, so you can look that over. If you have a question about that, or if you're not sure if you got your test score back, then let me know. Okay, so we only have 1 test left. There's only 3 weeks left. And there's only 4 sections left. I think we have plenty of time. So we have 5-2, 5-3, 5-4, and 5-5. Okay, even if I just do 2 sections a week, we should be fine. And that being the case, I'm more willing to give you a quote unquote tougher quiz on the 7th and also the 14th, realizing that we're almost done. Okay, now I'm not going to change the date of the test, but I may finish early. Okay, so please notice I plan on having Thursday the 20th for the last exam, not Friday, so I can have another day to review for the final. However, if I finish early, I'm not going to change the date of the test. Okay, if I finish early, I'm just going to start my review for the final. Okay, so I think it's better than I got a moving target. I don't know when, I'm going to finish everything. I just say, let's fix the last exam on Thursday the 20th. My original plan was, okay, I land exactly here, then I just have 1 day to review for the final? Well, if I finish early, I'll just, rather than giving you the test early, I'll just start reviewing for the final and still set the exam as being on the 20th. So that way I can kind of gauge where I am and not too worried about changing the date, but just to change, when we start reviewing for the final exam. Okay. You say, how do I study for the final exam? Just study the old exams, and I'll be reviewing the old exams for you. That's how you study for the final exam, just off the old exams. Okay. In terms of cheat sheets, you can bring all the previous cheat sheets. So let's say the cheat sheet that you had on test 1 and test 2 and test 3, you don't have to make them all over again. I hope you didn't throw them away. If you threw it away, you can make them again, I guess. But rather than reinventing the wheel and make it all over again, just keep the formula sheet you had for the first test, second test, third test, fourth test, and the fifth test, which is still to come, and just use them all for the final exam, okay? Rather than making it all over again. All right, so that's the game plan for now. So I'm in 5-2. I don't have to get that far. I can spend 2 days on it or even more. I've got some buffer days here. And I'm leaning toward giving you one of these longer quizzes again on the 7th and the 14th, because I do have extra days. And just like the last few quizzes, saying, well, I want to give you a complete curve sketch. It might be too much for you to do it on the test, but I'm willing to give it to you on a quiz. So I might do something likewise here. Okay, so we only have 3 weeks left and a final exam. Final exam, please notice the time, 8:10 to 10:40 on Monday, the 24th. That's school policy. I can't change the time. Okay, and notice it's 8:10, not 9:10, our usual starting time. So 8:10 to 10:40. Okay. All right. Any questions about that before we get started? Let me check the chat. Okay. So let's see. If you just joined, let me know. How many questions on the final exam, I assume, is what you're asking. It'll probably be more than 10. So likely 15 or 20, I'm guessing. If you're talking about the last exam, exam 5, we'll probably still have around 10 questions. Final exam, well, you have 2.5 hours, so it's probably not going to be 10. I'm taking 15 or 20. And the reason why I say 15 or 20 is if I decide to give you 3 questions per test, 3 times 5 is 15. If I decide to have 4 per test, then 4 times 5 is 20. So something like that. Okay, so I will look at the first test. Let's pretend I give you 20 questions on the final. I'll look at the first test and say, okay, I like this one, this one, this one, this one, and put that in the final. And then the second test, I like these 4. And the third test, I like these 4, and so on. Okay, if I decide to give you, say, 15, then same thing. I'll pick 3 from the first, 3 from the second, 3 from the third, 3 from the fourth, and 3 from the last test. I don't have to give you the very same question. I might modify it a little bit, although I'm allowed to, but that's how you study for the final exam. Just study off the old exams. Okay, it's too much to say study everything. Well, you know, it's very difficult to study everything that we've had. Okay, so that's how I'm going to do final exam. Okay, so any questions about that, please, before we get started here? Okay, all right, so I will begin 5.2. Now, a lot of 5.2 is theoretical. I may not even get started with any homework problems today, but that's okay, since we have the time for that. Okay, so hang in there a little longer. We only have 3 weeks and then a final exam, and that's it. Okay, so I'm already done with 4.9, 5.1. So 5.2, 3, 4, and 5. Let's set the date of the last regular exam is what I should say. It's Thursday the 20th, regardless of when I finish. If I finish early, then I'll just start reviewing for the final. But of course, you'll still have time to review, ask questions and answers for the test. So let's reserve Wednesday, 5/19, I suppose, as our usual day of review. But if I have time to start reviewing for the final exam, then I'll do that also. Okay. Okay, so 5.2. A lot of notation here. 5.2, the topic is the definite integral. Definite integral, which seems to imply we've done indefinite integrals, and that's correct. 4.9, when you were doing the antiderivatives, those were indefinite integrals. You don't really have to write that down right now. Okay, but let's see what's going on. Let's look at a little notation. Okay, right now, don't look at any of this stuff here. Just look at this notation. There's an integral sign, f of x dx. I showed you that in 4.9. But there's going to be a number here and a number here. So the integral from a to b of f of x dx is a definite integral. We don't know what it means yet. Okay. Now we do know what it means if I don't have the a and the b. Integral of f of x dx. That was from section 4.9, right? Find a bunch of antiderivatives, blah, 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 plus c, right? So you might recall the integral, if I don't put any number here, a and b, integral of f of x dx, like the integral of x squared dx was x cubed over 3 plus c by the power root, right? Okay, but this is different. Okay, so that was called an indefinite integral. A definite integral has a number here and a number here. So what does it mean if I have a number here and a number here? Okay, so first example, page 379. First, we have this guy named Riemann. I'll talk about him briefly, but not too much. Okay, look at figure 3, page 379. Now, in section 1, we were doing this stuff and estimating the area under the curve, right? And chop it up into so many pieces, right? So here it looks like I chop up into 1, 2, 3, 4, 5, 6, 7, 8 pieces. Okay, it looks like maybe they're picking the midpoints. Okay, so they go straight up, touch the curve, draw a rectangle, go straight up, touch the curve, draw a rectangle, and so on. Okay, all the functions we did last time were positive. Okay, now what happens if you have a function that's part positive and part negative, like this? Okay, so if you can ignore all the rectangles, just look at the curve y equals f of x. I'm tracing it out right now, right? Well, sometimes the graph is positive, sometimes it's negative. Okay, so if I take the interval from A to B, that's the same A and B as over here. Chop it up into so many pieces, they will tell us what the n is. So in this case, it looks like what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. They chop it up into 12 pieces. Chop, 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 chop. And they do base times height, and so on. Well, it looks like 1, 2, 3, 4, 5, 6 of the rectangles go down, right? So you can see that in yellow. Okay, those heights are negative. These are positive. Okay, 1, 2, 3. But if I'm going to do base times height, some of these are actually depths, D-E-P-T-H-S. You're going negative, you're going down. So positive, 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 negative, 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 right? And then some more positives. Okay. Figure 4 shows you what the meaning of that integral is. See the figure 4, integral from a to b of f of x dx is the net area. Okay. Net area meaning, see those two regions with a plus? Those areas are counted as positive, but see that yellow in the middle with a minus sign? That's considered as a negative. The integral from a to b of f of x dx is the net area where anything above is counted as positive, anything below is counted as negative. Okay, and furthermore, we're talking about the true value, okay, which right now we don't know how to do, but whatever this true area is, let's pretend this is 5, and let's pretend this is 4, and let's pretend this is a negative 6. Then the integral will be a positive 5, a positive 4, and a negative 6, which comes out to be 3 or whatever. Okay, so this symbol represents the net area. This right now, it's just a theoretical construct. We don't know how to do it exactly. Okay, but when we do base times height, and all that stuff, okay, just realize some of them might come out negative. Okay, now I agree with you if you're saying, boy, this seems to be totally different than the indefinite integral in section 4.9 when we were doing the antiderivatives. Okay, and I agree, but don't worry, in a future section we'll tie it all together and it all makes sense. Okay, so when you have a definite integral from a to b of f of x dx, we're talking about the true net area where anything above the x-axis like this is counted as positive, anything below is counted as a negative. We can approximate by doing these buildings again, so to speak, high-rise buildings, but everything above is positive, everything below is a negative. Okay, if I don't have the a and a b, it means give me a class of antiderivatives. Okay, so when you see the definite integral, figure 4, integral from a to b, that's a definite integral. There are definite numbers. So it means start at a, end at b. They'll tell you how many pieces you want to chop it up into. Okay, and we're talking about a net area. Now, if the function is completely positive, it is the area. Okay, there's nothing below. Okay, so what we were doing last time was to estimate the area under the curve. We were estimating this symbol, the integral from a to b of f of x dx. Okay, the area under the curve if it is positive. And how do we do it? Well, we do stuff like this. And we said we can choose left endpoints, we can choose right endpoints, we can choose midpoints, right? So that's all we did at the time. Okay, so now page 382, figure 5. They're trying to give an estimate for the integral from 0 to 3 of f of x dx, where the function is x cubed minus 6x. Okay, so here's the graph of x cubed minus 6x from 0 to 3. Okay, it looks like the answer should be negative. Okay, so if I take the area bounded by the graph and the x-axis, that looks like a pretty big region, and it's negative. If I look at this region right here, it looks like it's pretty small. Okay, so I would anticipate the answer to be negative. Okay, now in this case, they chopped the picture up into 1, 2, 3, 4, 5, 6 pieces. Okay, and I think it looks like they picked right endpoints. Yeah, right endpoint. So before, when I said go straight up until you touch the curve, now you just go until you touch the curve. It might be down. So down, draw a rectangle, down, draw a rectangle, down, down, up, up. Okay, so they added up this rectangle's area plus this, plus this, plus this. All 4 of these are counted as negative, you may notice. And these 2 are counted as positive, negative 3.9375. So that's our estimate for the integral. Okay. Figure 6. They came up with an exact value of negative 6.75 somehow. Okay. And that makes sense. If you look at region, they call it A2, that yellow area, that's a lot bigger than A1. So there's a lot more negative, which means stuff below the x-axis compared to stuff above the x-axis, A1. Okay. And their estimate was negative 6.75. Okay. Now we have to be careful about our language. We still always want to say that the area is positive. Area is a positive quantity. Okay. The integral is allowed to be negative. Okay. So this is an integral. Integrals can be negative, but area is positive. So if I had to, get paint and buy paint and paint this area, that would not be negative. The area is still positive. If I had to paint this, it's positive, but the integral could come out to be negative. Okay. Here are some estimates that they have. Same function. Notice they chop it up in a whole bunch of pieces, right? And there's a different ends. So n is 40, 100, 500, 1,000, 5,000 computer generated. Okay. And you can see they got what, negative 6.399, negative 6.61, negative up to negative 6.74, something like that. Okay. So as n gets bigger and bigger, it looks like we get closer and closer, or the language we will say sometimes is converge. We converge to a particular number, and they're saying that it's negative 6.75. Okay, so if you chop the region up into more and more pieces, the estimation gets better and better. The larger the n, the better the approximation, but of course, the more the work it is. So obviously, I wouldn't make you do anything like this by hand, but you computer science people can set up a program very easily to have the computer grind this all out, and it's about negative 6.75 or whatnot. Okay. Figure 8, y equals e to the x from 1 to 3. This time, the area under the curve is going to be the integral because this graph is always positive, which is what we want. Okay. And some more pictures here. Page 384. They've got figure 9. It looks like 1/4 of a region of a circle. We already know how to find the area of a circle. circle is pi r squared. That looks like 1/4 of that. So some of the homework problems, you're going to get either a circle or a part of a circle. And since we know how to find the area of a circle, we can do it. Okay, figure 10, likewise, rather than chopping up into so many pieces, right? A1 and A2 are both triangular regions. We know how to find areas of triangles, right? So we can just go 1/2 base times height for the blue, 1/2 base times height for the yellow, and then subtract A1 minus A2, and that'll be the value of the integral, right? But if you have a graph in general, like this one, they show, again, x cubed minus 6x, we don't have any nice shortcut for working it out except chopping it up into so many pieces. And they've got M40 there. M stands for midpoint. 40, they chop that up into 40 pieces, about negative 6.7563. Okay. All right, some properties of the definite integral. Okay, you can put this on your cheat sheet or not, it's up to you. Okay, integral from B to A of f of x dx is the opposite of the integral from A to B of f of x dx. Okay, so if I decide to go from 3 to 10, I'm going to get the opposite as if I go from 10 to 3. And you might think their area is the same. Yes, but it has to do with the delta x. Okay, your delta x, if I go from 10 to 3, it's negative. Okay, if I go from 10 to 3, like I go from 10 to 9, 9 to 8, 8 to 7, 7 to 6, that's negative. But if I went from 3 to 10, I'd be going, okay, from 3 to 4, 4 to 5, 5 to 6, that's positive. Okay, so we make it so that the integral from B to A is the opposite of the integral from A to B. Okay, that's going to be a little bit more crucial when we get to section 3. Here's another one. It should be obvious if you know what it means. Integral from A to A of f of x dx. Well, no matter what the function is, if I start at A and I end at A, it means I haven't gone anywhere, right? I just stay right there. So if I stay right there, what's the area? 0, right? So if I ever integrate from A to A, the answer is automatically 0. Okay, more properties of the integral. Number 1, integral from A to B of c dx is c times b minus a, where c is any constant. Seems reasonable. Okay, I'll actually show you a picture of that in a second. 2, the integral of a sum is the sum of the integrals. That kind of makes sense if I think of the indefinite integral case, where it was anti-differentiation. Okay, the derivative of a sum was the sum of the integrals. So the integral of a sum is the sum of the integrals. Jump down to number 4. The integral of a difference is a difference of the integrals. Okay, that was true for derivatives also, right? If I differentiate a difference, something minus something, just take the derivative of the first minus the derivative of the second. Likewise for integrals. And 3 is the constant multiplier root. See the constant c? You can factor the c out, take the c out in front. C times the integral from A to B of f of x dx, where c is any constant. Okay, you can write it on your cheat sheet or not. I think if you understand the principle, you don't have to. So number 2, it's pretty straightforward. So how do you integrate a sum? Just integrate the first, integrate the second. Number 4, how do you integrate a difference? Integrate the first minus integrate the second. If you have a constant times a function, number 3, just take the constant times the integral of the function. Okay, number 1, I'll give you a little bit more explanation on. Okay, number 1, if the function is f of x equals c, that means y equals c. What does y equals a constant look like? Y equals a constant, like y equals 7. What does it look like? Horizontal line. Right? Y equals c. We're going from A to B. The integral gives me the area under the curve. Well, for this picture, I don't need to guess. I don't need to chop it up in so many pieces. It's a rectangle. I know how to find the area of a rectangle. Base times height. What's the height? C. What's the base? This is A. This is B. The difference is B minus A. So the area is C times B minus A. Okay, so that makes sense. So that's the explanation of number one. Okay, the integral from A to B of a constant is the constant times B minus A. Okay. So there's really no need for me to go chop into a whole bunch of pieces. Okay. I don't have to guesstimate the area. I know how to find the area of a rectangle. Base times height. So the height is C and the base is B minus A. So C times B minus A. Okay. Okay, the next property is property 5, okay, which I'm about to show you, but I don't want you to see it quite yet. You look at figure 15. I know, I'll go like this. So you don't see what the rule is. Of course, if you have the book, you can just see it in the book. I'm trying to get my ruler here. So I'll let you guess what the rule is. Okay, I'm going to do a little bit of tracing here. So watch what I do over here, I guess. If I trace this and down and over, one more time, up, here, down and over. That's the integral from A to C of f of x dx. Okay. Now let me trace this. Up, there, down, over. Okay, one more time. Up, here, down and over. That's the integral from C to B of f of x dx. Right? All right, based on what I just did, what should be true about this whole region here? Up, all the way there. That's the integral from A to B of f of x dx. Okay. Well, I can get that whole thing if I take the integral from A to C and add it to the integral from C to B. Right? That's exactly what's going on here. So this shows it to you perfectly. Okay. Integral from A to C of f of x dx. Look at the picture and also the rule on number 5. Plus the integral from C to B of f of x dx. Look at the picture. It's the same thing as if I went straight from A to B in the first place. Integral from A to B of f of x dx, right? So this is kind of optional. Do you want to put that on your cheat sheet or not? You can kind of look at the picture and get it. Again, this is one of those things, though, that if we had met face to face, I'd make you memorize. Okay, but you can see it's not that hard. Okay, look at the figure. If I integrate from A to C, I get a certain amount of area. Then if I integrate from C to B, I get a certain amount of area. If I add them together, it's the same thing as if I went straight from A to B in the first place. Okay. All right, there's properties 6, 7, and 8. They're not really that important right now. You can look at it or not. I'm just going to say they're there, they're true, but I wouldn't bother putting it on my cheat sheet. In fact, I'm barely going to talk about it at all. Okay. All right, so I think I'm going to get ready to start some of this. So 5.2, get started with some of it. First, you see the words Riemann sum. So what is this Riemann sum stuff? Okay. When we were doing base times height, base times height, base times height, base times height, add them all up, that's a Riemann sum. That's basically all it is. Okay. One big difference between section 1 and section 2 is that sometimes the graph is going to be negative, right? So we already did stuff like this, like number 5, except see, sometimes the graph goes below the x-axis. Same thing for 6. Same thing for tables. Okay, before they were always positive. Now there's going to be some positives and negatives. Okay. All right, so let me go ahead and give you the book for those of you that don't have the book and aren't getting it. So we had to go up to what, 41? Check to make sure that I wrote it correctly here. Yeah, 41 is our highest problem. Okay, so there's that, there's that, and that, and the table. And let's see, 9, 10, 11, 12, and 21 through 25-ish. And we don't have to do those. Then 33, 34. Then on the next page, we had to go up to 41. And there we go. Okay, actually, now that I'm here, let's get 41 out of the way. Can you guess the answer to 41 immediately? Integral from 1 to 1 of square root of 1 plus x to the 4th dx. Doesn't matter what the graph looks like. How much area is there if I start at 1 and I end at 1? 0. So the answer to 41 is automatically 0, right? There's no area. You start at 1. So what does the graph look like? I don't know. I don't care. If I start at 1 and I end at 1, there isn't any area there. Now, if it told me to start at 1 and go to 2, then that's some work, right? There's going to be some graph. There's going to be some points, and then, you know, chop up into so many regions. But if I'm starting at 1 and ending at 1, we don't really care. The answer is automatically 0. Is that right? Okay. All right, so number 1 and 3 are kind of similar. I'll do number 3 for you. If f of x equals x squared minus 4, x is between 0 and 3, find a Riemann sum. Okay, don't get scared by that expression Riemann sum. You were doing Riemann sums last time, base times height and so on. N equals 6, and take sample points to be midpoints. What does Riemann sum represent? Illustrate with a diagram. Okay. Getting a message that says my internet connection is unstable. So if I cut out, give me some time to come back. Well, we only have 15 minutes left anyway, but we'll see how it goes. Okay, so how do I do number 3? Okay, f of x equals x squared minus 4 between 0 and 3. Chop it up into 6 pieces and pick the midpoints. So what is my delta x? I already showed it to you, but you didn't. Okay, the length of the interval is 3 from 0 to 3. Chop it up into 6 pieces. So delta x is 0.5. Right, how do you get that? 0 to 3 is 3 units divided into 6. 3 divided by 6 is a half, or 0.5. What does x squared minus 4 look like? Parabola opening up. Okay, think of x squared, right? Vertex is the origin. What does the minus 4 do? Go down 4 units. So here we go. So it crudely goes like this. I was going from 0 to 3. And how do I know it touches 0? When you plug in 2, you get 0, right? So I know it goes like that. Parabolic, so something like this. Okay, delta x is 0.5. So 0.5, 1, 1.52, 2.53. So I have 6 sub-intervals. Okay. A sub-interval is a smaller part. It's still an interval. It's a full-fledged interval, but it's a part of the original interval. The original interval was from 0 to 3. So the sub-intervals are from 0 to 0.5, 0.5 to 1, 1 to 1.5, 1.5 to 2, 2 to 2.5, 2.5 to 3. Okay. All right, so we can pick the left endpoints, the right endpoints, or the midpoints. In this particular case, they told us to pick all the midpoints. All right, so where's the first midpoint? 0.25. Okay, I'm going from 0 to 0.5, right? So what's the midpoint? 0.25. And What's halfway between 0.5 and 1? 0.75. And just keep going. Halfway between 1 and 1.5, 1.25. Halfway between 1.5 and 2, 1.75. Halfway between 2 and 2.5, 2.25. Halfway between 2.5 and 3, 2.75. So I picked all the midpoints. There, 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 there. Okay. And then, yeah, last time I would say go up until you touch the graph and draw a rectangle. We're here in 4 of the instances, I have to go down. Okay, so I'll just say start from your midpoint, go until you touch the graph, whether it's up or down. So in this case, I go down, draw a rectangle. This one I go down, draw a rectangle. This one go down, draw a rectangle. This one go down, draw a rectangle. But finally, for the last 2, I do go up, right? These 2 I go up, draw a rectangle, draw up, go up, draw a rectangle. So just eyeballing it offhand, it looks like the answer might be negative, because it looks like there's more area below than above. Okay. So when it says Riemann sum, that's what we're doing. Find the Riemann sum. All right, so it's base times height, but height is in quotes. 4 of these are actually depths. You're going down, D-E-P-T-H-S. Base times a depth, it's going to be a negative. Base times height, base times height, base times height. So I'll keep saying base times height if you realize height can be negative. Okay. So there's 1, 2, 3, 4, 5, 6 of them. All the bases are the same though, 0.5. So it's a lot easier to factor out the 0.5 and then just do all the heights once and for all. So it's f of 0.25. Careful, it's not 0.25, it's f of 0.25. That means the y coordinate when x is 0.25. And f of 0.75, and f of 1.25, and f of 1.75, and f of 2.25, and f of 2.75. These are the 6 midpoints of these subintervals. Okay, then what do I do with all these? I take all of these and plug them into the function x squared minus 4. And here's what they all come out to be. You can punch this out on your own. Okay, but when I plug in 0.25, 0.25 squared minus 4 is that. 0.75, plug it in, 0.75 squared minus 4 is that. And of course, you can punch this out on your own, verify that on your own later. 1.25, plug it in, 1.25 squared minus 4 is supposedly that. And just keep going. 1.75, 1.75 squared minus 4 is that. So negative, 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 negative. And finally, it looks like we get some positives. F of 2.25, 2.25, 2.25 squared minus 4 comes out to be that. And finally, 2.75, plug it in, 2.75 squared minus 4 is that. So I add 1, 2, 3, 4, 5, 6 numbers up, and then multiply by 0.5, negative 3.0625. So that's my estimation. That's my estimation in this particular case. Okay. All right. Okay, so that's it for that one. Let me just do the focus thing right here. There we go. Okay, so last remaining bit of time. I won't have time to do much more, but let's see. There was an even problem number 6. I'll start you off with that. That's about it. And this is unfortunate again, where since we're not meeting on campus, if we met on campus, I can project this and write on the board. but I can't do both of these at the same time. So number 6, the graph of G is shown. Estimate the integral from -2 to 4 with 6 subintervals using right endpoints, left endpoints, and midpoints. Okay, this one's a little bit tricky because this is considered 1. 2 squares is 1. So this is 1, 2, 3, 4. So this is 4 right over here. And -1, -2. Okay, so I don't even know why they have that last one. The only part of the graph that you really want is up to here, right? Okay, chop it into 6 subintervals. How far is it from -2 to 4? 6. 4 minus a -2. They want 6 subintervals. Perfect. The length is 6. They want n is 6. So delta x is 1. Okay. So right here, right here, right here, right here, right here, and right here. So we're going to pick the right endpoints, left endpoints, and midpoints. Okay. So I'm going to go from -2 to -1, -1 to 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4. If I were going to pick the right endpoints, then on each smaller subinterval, pick the right endpoint. So this case would be -1. What's the next right endpoint? 0. From 0 to 1, right endpoint, 1. 1 to 2, 2. 2 to 3, 3. 3 to 4, 4. Those are the right endpoints. Left endpoints. So from -2 to -1, left endpoint is -2. -1 to 0, -1. 0 to 1, left endpoint is 0. 1 to 2, 1. 2 to 3, 2. 3 to 4, 3. Okay, the last one is the midpoints, and this is what I want you to do. Okay, give me the 6 midpoints on each subinterval. Okay, so that's it. Between here and here, what's the midpoint? Midpoint, 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 midpoint. Type in those 6 midpoints in the chat and you can leave and I'll see you tomorrow. Okay, so on your way out the door, what's the midpoint of each subinterval? What's midway here, 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 and here. And that's it, and I'll see you tomorrow. Okay, so just type it in the chat. You can do it privately, and then we're done for the day. Okay, so just give me the 6 midpoints, okay, on each subinterval. Okay, yeah, I'll leave the book as it is, so you can have that there, and then we'll be done. Should not be that hard. They're basically all the halves. Here to here, 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 here to here. Okay, as soon as I get it, then you can leave and I'll see you. Anybody who joined late, put your name in the chat and I'll get you for attendance a little bit later. The screen should not be frozen. I think you can still see it. Sure, if you can see it, I'll raise it up if it helps. Okay, so again, I'm just asking for the midpoints. What are the 6 midpoints for each of the smaller subintervals? There, 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 and there. If you want an even bigger hint, they should all have a 0.5 in it. Okay, how's that? Some are negative and some are positive, but they're all going to be a 0.5 half somewhere. It's about 9:57, so I'll close up at 10 o'clock, so a little bit less than 3 minutes. 2 minutes now, I guess. Okay, folks, I'll be closing up in a second, so just make sure time something again. I'm not going to dock you for not putting anything down, but the thing I like the least is if you don't try, you don't participate. Okay, so perhaps I should say, you don't get docked for the wrong answer unless it looks to me that it's obvious you're not trying. But if you consistently do one of these in-class assignments and I see you don't put anything down, that's what I don't like. And you may lose points because of that. Okay, so I want you to at least give it a try. Okay, I'll be closing up pretty soon, so please put something down. Anybody who joined late, put your name in the chat so I can get you for attendance. Okay, folks, it is 10 o'clock, so that'll be it for today. Everybody have a good day, and we'll see you next time. Okay, all right, bye, everybody.